Hello, my name is Junlin Liu, and my project topic is BER performance analysis of WCDMA system using different spreading code generators. First of all, let's look at the traditional transmission system. Here's the message, and the message goes through the transmitter, and then the transmitted signal goes to the channel, then pass through the received signal to the receiver side and get a message. Here's a baseband application system. The difference is that there's a pulse shaping filter, and then goes the AWGN channel and to the match filter and to the decision device, and then get a decoded bit. But in a room, you have so many limits. You have frequency limits, time limits, and code limits. So we use multiple assets. The first asset is the frequency frequency divide multiple assets. We divide the frequency into different parts, and then use this frequency to transmit signal. The second type is the TDMA system. Use time divide multiple assets to transmit some signal. The third one is the topic today. The TDMA system code divide multiple assets. Let's look at the WCDMA base system. This is the base station, and this data. This is binary data -1 and 1, and then I use spreading code. This spreading code can be generated through different ways, and then we multiply data and the code, and we get a message. And at the receiver side, we have the spreading code, and then we use the spreading code, and then we can get the data back. This way of the WCDMA system. Then the topic today is spreading code. For WCDMA system, we have many spreading code. We have PN sequence, wash code, go code, hard mark code. And in this project, I focus on PN sequence, wash code, and go code. As we all know, PN sequence is deterministic generated, but it has some root, so it's almost like random sequence. For the go sequence, go sequence are obtained from a modular 2 addition of maximum length sequence. For wash code is a spreading code that with less spreading factor. Wash code are used in direct sequence and frequency hopping spread spectrum. And to evaluate these three spreading codes, we use the BER bit error rate to evaluate the performance of this spreading code. Here's the MATLAB Simulink simulation model. Here I have turned on the MATLAB Simulink, and this is the go sequence generator. And then go sequence generator the signal goes to the modulator MPSK. M is QPSK, and the M is 4, and then goes to the small scale fading. Here I use a rated fading channel, and then I use a raised cosine transmit filter, and use the AWGN channel. Then goes to the raised cosine receive filter, and goes to the QPSK demodulator baseband. Here is the bit error rate calculator. From here is the input, the first input, and here is the signal after modulation and demodulation, and it goes through some channel simulation. Here I add a display block to display the bit error rate. In this part, I set the sample time as 0.000 seconds, and I set the sample per frame is 5 samples per frame. In the multiple rate fading channel, I set the maximum Doppler shift as the 0.001 Hz. In this block, the AWGN channel simulation block, I can set the SNR. At first, I set the SNR at 0, and then I increase the SNR by 2, and then run the simulation, and then I add 2, which is 4, and then I run the simulation again all the way until 20, and then compare different generator, the results of different generator. As for this block, this is the disk block. Here's 3 numbers on the block. The first number is the bit error rate, 0.7593. The second number is the arrow signal, and the third number is the total signal that I have transmitted. Here I can set the simulation running time. At first I set it as 50, and then I can click the run, and then I get the result. As you can see, every time I change the running time, and the result will be different. And every time I change the SNR, the result will be different too. And I show you the PN sequence generator is almost the same. Difference is the generator. I use the PN sequence generator, but the watch code generator is a little bit different, because watch code generator in simulating watch code generator produce the signal, produce the output is 1 and -1, but for QPSK block, it can't accept the input -1, so we have to change the minus number into positive number. Here I add a compare to 0 block to convert the -1 into 1, so I finally can run the simulation. Note, here we have to set the sample time as the 0.008, which is the same as the simulation I did, and 5 samples per frame. Here's the SNR. In order to compare the different performance, we have to set the SNR as the same, and then run the simulation. We can see the difference between the watch code and the code sequence generator and the PN sequence generator. In this way, we need to write down the data we get. I use Excel to write down all the data that I got from the simulation. As you can see, there's the data of the when SNR is set to 0 and the time set to 60 seconds. There's the bit error rate, and then we can compare them. And then I set the time to 500 and then to 1100. This table is a little bit different. The table is about the error amount, and this is the bit error rate. Actually, the signal they transmitted are the same. The size are the same. And finally, we use MATLAB to plot the data we get. Here's the first. This is the first plot. The plot is about the relation between SNR and the bit error rate. This plot is about the BER of WCDMA system using 3 different spreading codes in 50 seconds. As we can see, when the SNR is lower than 9, the PN sequence performs better because it has a lower bit error rate than the other 2. But when the SNR increase to greater than 9, the wash code is better than the other 2. This is the result of the 50 simulation. And then the 500 seconds result is a little bit complicated. When the SNR is less than 10, then the wash code performs better than the other 2. When the SNR is greater than 13, and wash code is better than the other 2. But when SNR is bigger than 19, and the gold code is the best. But when SNR is between 10 and 13, the PN sequence performs the best. It's a little bit complicated. Then it's the 1000. In this situation, when the SNR is less than 11, the PN sequence is the best because it has the lowest bit error rate. But when the SNR is greater than 11, the gold code is the best. To specify, this situation is most close to the most closest to the real life, because in real life the WCDMA system has to run every second. We can't stop transmitting signal. So in real life, actually, we should set the time as big as possible. When you increase the time, simulation costs much time than before. So 1000 times proper for us to evaluate the free performance. So in real life, the gold code is the best. Thank you.